your SQL can be correct and still be a red flag. In this video I will show you SQL anti-patterns that make you look like junior, in my experience at least, and ways how to fix them. If you don't know me, welcome to my channel. I am Ruslan Brylenkov, a senior data scientist working here in Canada, and I deal and review SQL a lot. I will show you bad version and better version of SQL. First, quick definition. An antipattern is a habit that looks normal at first, and it might even work, but it creates problems later down the road, such as bugs, slow queries, confusing code in reviews, painful maintenance, and so on and so forth. So in this video, I'm not only showing you wrong SQL, but the patterns that technically run and work, but make your life harder in the long run and make you look less experienced. I will show you 8 anti-patterns which are common. Even smart people do them, even I do them sometimes, let's be honest. But if you can fix this, your SQL becomes much clearer, more correct, and usually faster. So without further ado, let's jump right into the first one. Anti-pattern 1. Select star in anything serious. It feels convenient, but it is fragile. It breaks when schemas change. It pulls columns that you don't need. It makes reviews much harder than they have to be. Quick pause here. Hi, this is Ruslan from the future, dropping in with a quick extra point. Essentially, why select star in production is a bad practice. It creates hidden dependencies, meaning that new columns can quietly change results or payload size. Here is the senior version of the same query. Select really only what you need and name it clearly. A simple rule to follow in this case: if it's not a quick exploration query, don't use star. Anti-pattern 2, using limit without order by. As you can see, we are limiting the first 10 entities, and this is basically random. It might look stable until it doesn't. In other words, without order by, you cannot reliably reproduce the same results. In production, it will change everything, but the fix is really easy. Always decide what your top means, then sort accordingly. As you can see here, we are ordering by total amount in descending order. The rule of thumb: if you want latest, sort by time. If you want biggest, sort by value. Anti-pattern 3, in functions inside the where clause. This often kills index usage and makes queries much slower than they have to be. You are forcing the database to compute per row instead of using an index. And for example, consider using this literal date instead of wrapping the column in the function. A better approach can be moving logic to the constant side, then using a range. This is cleaner and usually faster. Anti-pattern 4, an accidental inner join with left join filters. So you write a left join, then you filter the right table inside the where clause, then you can turn it in an inner join, and you silently lose rows. Essentially, if you want to keep customers with no orders, this is wrong, because when you do the where clause, for example, in this case order date, right after the left join, this removes all the nulls, where the order date is essentially null. You asked a database for all customers and filtered out those with no match. The fix is relatively easy, is to move the filter inside the joining conditions. A query look like this. Rule of thumb: filters for the join table often belong in on clause, not where clause, when using the left join. Anti-pattern 5, using distinct to fix duplicated rows. If you are using distinct because joins explode rows, you are not fixing the cause, you're just hiding it.
Distinct can also be expensive and it masks real data issues. Of course, if you want and need to get a unique set of rows after all joins are corrected and checked, then of course use it. Otherwise, here is a fix.
The fix is really to ask the real question. What do you want to do here? If you want customers who placed at least one order, then use exists clause as an example. And here we can see that we simply add the where clause where exists and make essentially the subquery inside this query. That treats like an intent and it avoids row explosion, and you don't really hide the duplicated rows by using distinct. Antipattern 6. Correlated subqueries when a join or aggregation is clear to use. And correlated subqueries are not always evil, but they are often a junior habit because they feel somehow obvious.
They can run once per row, which is harder to tune.
For example, total spent amount per customer. What is actually better to use is to aggregate it once and then join, as you can see in this case. This is easier to tune and easier to expand as well. Antipattern 7. Not in with nulls. If you remember only one thing from today's video, remember this one. This is actually a classic trap. If the subquery returns a null, not in can return 0 rows. It looks like there is no data, but it's actually the problem, the logic.
This is 3-valued logic biting you, because null means unknown, so not in clause becomes unknown too and filters everything out.
The way to avoid this, we can use the not exists instead of not in. It behaves exactly how we would expect. The last one in the list is the big or conditions. They get messy very fast and they often perform badly, selecting different columns, which slows down the query performance.
The optimizer often cannot use indices effectively across wide or branches, because different columns mean different indices to juggle.
So instead use in clause. It's simpler and usually easier for the optimizations too. If your OR mixes totally different logic branches, consider using union all as well. It can be clearer and sometimes faster as well. These are small habits, but they signal seniority and also help to avoid or fix real-world production bugs. If this helps, subscribe to my channel, tell me which anti-pattern you see the most. See you next time.